Hi class, in this recording we're going to talk about the hormones associated with male puberty. And thankfully, for at least on this recording, for the male end of the spectrum, the hormones aren't quite as convoluted as they are on the female end of the spectrum. As we look at the male reproductive system, for the first 10 to 12 years in the vast majority of boys, the reproductive system is going to be dormant. And, there's some outliers. Occasionally you'll see a 9-year-old boy entering puberty. Occasionally you see a 13 or 14-year-old boy entering puberty. And particularly for these young men that are entering puberty, a key sign that is happening is their voice will crack. And I remember for myself in particular, my voice cracked right when I was ending 3rd grade is when my voice started to crack. And it was awkward. I was one of those I was on the early end of the spectrum for hitting puberty, which I wish was a little bit different in hindsight. But as we look at these, when males enter puberty, we find that there's going to be a lot of gonadotropins. And, this is a term that we talked about with the endocrine system. Gonad is a root word that refers to, well, the sex glands. So for males, the testes. For females, the ovaries. And a tropin is a root word that refers to a hormone that goes to another gland and causes that gland to make a secretion. So that's what tropin means. So these hormones are going to go to the gonads and cause the gonads to make a secretion. And they come from the pituitary gland. So the pituitary releases hormones that cause gonadal secretions. Pituitary gonadotropin. It's kind of a convoluted word. Now, when we look at adolescence, this is going to be the period that will start at gonadotropin secretion. The moment that we have gonadotropin secretions begin, all the way until that person attains their full adult height. So for males, this adolescence can last all the way up until about 21, 22 years of age. Usually males are still going to be growing a little bit taller. For females, they're usually done growing taller about 16, 17 years of age. Puberty is known as the first several years or few years of adolescence. For females, this is going to be until the first menstrual period. So the period of time from the gonadotropin release to the first menses. And then for males, it's the period of time from the first gonadotropin release until that first ejaculatory event. And for boys, puberty is typically going to, the first ejaculatory event typically is around age 14 in boys, and the first menstruation event is typically around age 12 for young ladies. Now, as we look at the testes, aka the testicles, are the male gonadotropin, and they're going to secrete testosterone. And that testosterone is going to be secreted during fetal development, during the first trimester of fetal development, and that's going to be the first 12 weeks after conception, is that first trimester. And that those testes are going to secrete testosterone all throughout the male's lifespan. But when we think of teenage boys having crazy high testosterone levels, yes, that's true. But when you were a fetus in utero, you also had, for the males at least, you also had crazy high testosterone levels during that first trimester. And after that first trimester, the testes become rather dormant. They're still going to be releasing testosterone, but not that much testosterone until that male enters puberty. And then from puberty to adulthood, we're going to have a series of positive and negative feedback loops between the hypothalamus, pituitary gland, and the gonads to regulate the hormones within the male reproductive system. We're going to camp on this slide for a while. So let's back up a little bit here. If we have a brain, here's the human brain. So we have the cerebrum, here we have the cerebellum, and then here we have pons, medulla oblongata as part of the brainstem. So here's our human brain, and then I'm going to switch to red here. We have that pituitary gland that hangs down right there, and the hypothalamus is going to be embedded right in the middle of the brain. So this is my really cheesy looking brain sketch. But now this is going to give you a frame of reference. This pituitary gland that I drew right here is diagrammed right there. And then we have the hypothalamus immediately superior to the pituitary gland, which is the infundibulum connecting them. So as we look at the hypothalamus. That hypothalamus is going to release GnRH, gonadotropin releasing hormone. Gonadotropins are hormones that cause the gonads to make secretions. Gonadotropin releasing hormone is a hormone that goes to the anterior pituitary and causes the anterior pituitary to release gonadotropins or gonadotropes. The two gonadotropins released from the anterior pituitary gland are FSH and LH, follicle-stimulating hormone and luteinizing hormone. And those two hormones will be secreted into the bloodstream and make their way to the testicles of the male penis, or of the male's external genitalia. And as we look at follicle-stimulating hormone, that follicle-stimulating hormone is going to act on nurse cells within the testes, causing those nurse cells to release androgen-binding proteins that will bind to testosterone and keep that testosterone within the seminiferous tubules. We haven't talked about those yet. The seminiferous tubules are the small, hollow passageways within the testes. So if you've ever had a chance to palpate a testicle, one of the reasons why you'll find that they're kind of squishy and spongy. And one of the reasons why they're so squishy and spongy is because they're filled with lots and lots of tiny hollow tubes, seminiferous tubules. This is also a key reason why they're so stinking sensitive. Testes are able to be damaged very easily because of all these fine, tiny seminiferous tubules that can be destroyed with crush injuries. So as we look at those nurse cells release androgen-binding protein that keeps testosterone in the hollow space of the seminiferous tubule. And that testosterone is then going to stimulate spermatogenesis. Genesis is a root word that means create or to create. What's being created? Sperm. So spermatogenesis is the creation of sperm. And then we also are going to look at luteinizing hormone. And that luteinizing hormone is every once in a while going to be referred to as interstitial cell stimulating hormone. Oof, duh. I'll admit, I am not a fan of that name. I'm a little old school and crusty, and I'm going to stick with luteinizing hormone because this hormone within the female reproductive system causes the formation of the corpus luteum, hence the name right here. But if you're only going to have a male-centric point of view, calling it interstitial cell stimulating hormone does make sense. But I'm not a fan of doing that. So as we look at this luteinizing hormone, it's going to stimulate the interstitial endocrine cells, also known as the Leydig cells, for those of you who are a little bit older and crustier. So the luteinizing hormone in males stimulates Leydig cells, also known as the interstitial endocrine cells, to make testosterone. And then that testosterone is going to be kept in the seminiferous tubules by the androgen binding protein that's been released by the nurse cells. Whew, that's a lot. So as we're looking at this slide right here, or the figure here, we can see nurse cells releasing androgen binding protein, and the interstitial cells releasing testosterone. Some of that testosterone is going to be stuck in the testes, seminiferous tubules, by the androgen binding protein, stimulating the production of sperm, spermatogenesis. We're also going to have testosterone exiting via the bloodstream, going to the rest of the body, causing those lovely secondary sex characteristics. I remember that, like for me, when my voice cracked, or the acne, or the getting really hairy and having skeletal muscle mass increase, those things. And then over here we have the development of secondary sex organs as well. Let's go ahead with one more slide here. I don't want to get ahead of myself. Actually, I did get ahead of myself here. So let's stay on this slide for a little bit. We should emphasize right here, while we're looking at this figure, that the nurse cells also are going to release a hormone called inhibin. And that inhibin is going to neutralize follicle-stimulating hormone, make it so that those nurse cells aren't going to be able to respond and be stimulated by follicle-stimulating hormones. So the nurse cells, in addition to releasing androgen-binding protein, also release inhibin. And the inhibin is going to cause the nurse cells to have down-regulated activity. As we look at testosterone itself, it will travel to the hypothalamus and cause the hypothalamus to not release as much gonadotropin-releasing hormone. Testosterone also is going to travel to the anterior pituitary gland and make it so the anterior pituitary gland is not as receptive to the gonadotropin-releasing hormone, which is released. So in addition to testosterone causing a bunch of secondary sex characteristic development, causing spermatogenesis, testosterone also is going to down-regulate the release of gonadotropins. While we're on this topic right here, let's talk about bodybuilders and steroids. A common side effect that most high school health teachers talk about with taking androgenic steroids is that it causes your testicles to shrink. And nobody, I shouldn't say that, most males I've talked to find the idea of having shrunken testicles to be pretty repulsive. And the idea behind this is that if you are artificially taking testosterone and elevating your blood testosterone levels, you are artificially going to be down-regulating the GnRH concentrations, artificially down-regulating the FSH and LH concentrations. And if you artificially down-regulate luteinizing hormone concentrations, you will down-regulate the development of those interstitial cells, or the Leydig cells within the testes. And the Leydig cells start to become dormant, inactive, and begin to involute on themselves. They become, instead of swelling up with testosterone, they start to shrink and become inactive, causing the size of the overall testes to decrease in response to taking artificial steroids. So as we look at puberty within males, in the male, we're going to have growth of sex organs. So the penis is going to increase in length and mass. Testes will descend and become larger. The scrotum becomes larger as well. Also, there's going to be development of pubic hair on the scrotum. The ducts and glands within the male reproductive system are also going to expand in volume and size. That testosterone is going to cause limbs to elongate. We're also going to have an increase in skeletal muscle mass, and the laryngeal prominence on the larynx is also going to enlarge. So what we find, and the larynx as a whole enlarges, and that enlarging of the larynx is one of the things that is contributing to the deepening of the male voice. And as we look at the effects of testosterone, it's really hard to downregulate how profound testosterone is on the body. Males are taller on general. They have longer limbs. Their increased muscle mass is going to also cause them to have increased skeletal density, increased bone density. So they'll have longer bones, which causes them to be heavier and have increased bone density. They have increased muscle mass, which causes them to be stronger and also have increased bone density. They also are going to have upregulated erythropoiesis, so they have the ability to transport more oxygen per milliliter of blood compared to female blood, or blood that hasn't had elevated testosterone exposure. Their BMR goes up because of that increased skeletal muscle mass, and they also eat a ton. We also are going to find some other things that happen for males when they're exposed to the puberty. For instance, they have pubic hair and axillary hair and facial hair developing, and that's going to be in response to dihydrotestosterone, DHT, which is a precursor to regular testosterone. And as we have the development of these hairs on the body, we're also going to have the development of the apocrine sweat glands, which are the stinky sweat glands, and then we also have upregulation of sebaceous glands. So in response to DHT, dihydrotestosterone, males tend to be stinky and pimply because of upregulated apocrine sweat glands and upregulated sebaceous glands. We also find that males, particularly when they are teenagers and have very high testosterone and dihydrotestosterone concentrations, have upregulated sperm production. So males have their peak fertility in their late teenage years to early 20s, and they also have peak libido which is associated with those peak sex hormone concentrations. So the male libido tends to be the highest during the late teens and early 20s, and then as the male ages and has lowering concentrations of these sex hormones, libido in the male generally goes down slowly. Not that much, but it goes down slowly as the male ages. Now, once that male reaches adulthood, that testosterone the male has, throughout adulthood is going to sustain their reproductive tract and sperm production and libido, which is one of the reasons why, even though the male maybe doesn't have as high of sex or as high of testosterone and dihydrotestosterone concentrations, males, generally speaking, are going to have high libido or high sex drive, typically until about their 50s or 60s, when there's just been a gradual, slow decline over the decades of these sex hormones. As I mentioned on a couple slides ago, the nurse cells produce inhibin, and that inhibin suppresses follicle-stimulating hormone output, FSH output, from the anterior pituitary gland, and will downregulate sperm production. And it's one way that we can downregulate sperm production without downregulating testosterone production. Testosterone is going to cause the downregulation of both luteinizing hormone and follicle-stimulating hormone. Inhibin only downregulates follicle-stimulating hormone. Let's just back up a slide here. There's one more thing that I wanted to mention. As we look at these changes that occurs in the male body, the elongation of the limb, the increase in skeletal muscle mass, and the corresponding increase in bone density, these are things that are very difficult to reverse. Even if the male has a decreased testosterone concentration, or maybe has an accident that causes the testes to be damaged. For instance, I have a cousin who shall remain unnamed, who has only one testicle. Those individuals can still maintain their skeletal muscle mass just with some regular physical activity, and can maintain their bone density, and obviously their arms and legs don't grow shorter in response to that downregulation of testosterone. So that's all we have for this recording. Let's go ahead and end it here. If you have any questions or comments, please feel free to let me know, and I'll do my best to get back to you as soon as possible. And as always, happy studies.